Thank you very much to all. We are starting now our session about mathematics and physics. At first sight, it seems that mathematics and physics have little to do with the major issue of this conference, namely consciousness, because mathematics and physics are supposed to be very abstract sciences, whereas consciousness is the most concrete, the most present thing that we have. Yet the implications of these so-called exact sciences for the problem of consciousness are very many. First of all, mathematics and physics are elaborated obviously by conscious human beings, and it's quite important to evaluate the mark of this origin on the structure and contents of these sciences. Secondly, if physics can claim to be a faithful representation of reality, then it's natural to expect that it will bring light on a crucial aspect of reality, such as consciousness. This is an implication of the so-called realist philosophy of physics. It's not an implication of physics by itself. It's an implication of a certain philosophical interpretation or reading of physics. But if physics, according to another philosophy, is less than a representation of reality, if it is only a sophisticated way, a sophisticated method for betting about the outcome of our experimental or technological actions, then it gives us a very different lesson about consciousness. Physics here, in that case, in that philosophical reading, suggests that consciousness should be taken as a presupposition rather than an object of physics. But physics and mathematics can also provide us with other things. They can provide models of the brain functioning that are more elaborate than those of biology, and therefore renew our understanding of the correlation between neural processes and mental processes. They can also provide more directly models of mind processes which can be compared to our experience of them while we are most attentive to them, namely during yoga or meditation. These are some of the topics which will be addressed during this rich afternoon session, and therefore now I call our first speaker, Ralph Abraham, who is the founder of the Visual Mathematical Project at the University of California at Santa Cruz. Thank you, Ralph.
Oh, when the saints, oh, when the saints, oh, when the saints go marching in, oh, I want to be in that number when the saints go marching in. This is called a spiritual, so-called spiritual, the 100% American equivalent of bhajan. And this particular one is calling in the saints, so the Gurujis, the Babajis, the Rishis, and so on, to come in and attend to us. And I particularly want to call the entities of all planes who had any responsibility in bringing me here today, so that I can thank them from the bottom of my heart as this being here in this time and place and event experience phenomenon. It's very important to me and to my life. So as far as consciousness, cognition, and culture is concerned, I am a mathematician and no more, and so I'll be addressing some relevance, I hope, to mathematical consciousness, mathematical cognition, or perception, or discovery, and mathematical culture. Now, mathematics and mysticism are, both of them, very large domains, so we might have a lot to do, but don't worry. My intention is a kind of first-person report on my life of some 60 years or more on the the fractal boundary between mathematics and mysticism. So, as far as mathematics is concerned, I should just signal the small niche of this huge domain where I've had my personal experience over these 60 years. And this is in a relatively new branch of mathematics called dynamical systems theory, or also known as global analysis. This was created by Poincaré, and so I'm in the lineage, as it were, of Poincaré, along with many other mathematicians today. This little branch, new branch of mathematics includes nonlinear dynamics, chaos theory, catastrophe theory, nonlinear oscillations, many other specialties spread over a large area of the domain of mathematics. This is an image from my current research. I just share with you because I have the ambition or the intention to engage artists and artistic technicians in the research of mathematics. As far as chaos theory is concerned, universities have largely dropped it at the moment, although in my view, of course, as a specialist of chaos theory, I think that it's extremely important and it should be studied in every university, math department, and so on. But it's not. So my intention then to get some research done promptly in this important frontier of chaos theory is to draft artists in to help me in the research. In this connection, I give a course every year at my University of California, Santa Cruz, called Chaos, Fractals, and the Arts. And the students in this course will learn something of the mathematics, something of the computer science, and something of the art of chaos theory. So in the upcoming instance of this course, starting in about 3 weeks, this image will be the starting point. As far as mysticism, of course, this is an even larger domain, especially considering the fact that it's not even defined. But here again, I can signal out just the small niche in which I've had my personal experience over these years. First of all, there's a guru called the Guru lines, where I had an affair with a guru in the Himalayan foothills more than 40 years ago, which changed the direction of my career and has been very important to me ever since. And the other domains in the mystical direction that have affected me equally are psychedelics, where I had an experimental period lasting about 5 years, but also many years ago, and meditation, which has been my lifelong partner since the age of 14, and divination, which I took up in the 1960s, particularly astrology and the consultation with the I Ching. So somehow all of these lines of mysticism are related and have impacted my research work in mathematics and vice versa. As far as vice versa is concerned, one of my hobbies is using mathematics to assist in understanding, communicating the cosmological models of all the ancient traditions. So I'll want to talk about my personal experience of this fractal frontier in 2 parts. And first I'll talk about this work on the quantum vacuum, which is a joint project I've undertaken with your Professor Shishi Roy. It's all his fault. First of all, I've been trying to trace back, and I'm probably not done, and many of you here can help me trace back the genesis of the idea of associating the Akash or any idea of space in spiritual or scientific traditions with the quantum vacuum. As far as I've found so far, the earliest I came across is this N.C. Panda in his first book, 1995, called The Vibrating Universe. This attracted my attention right away because vibration is one of the main metaphors that I learned during my stay in the Malian foothills. So he was primarily a scientist, but he seemed to be extremely knowledgeable not only in physics, quantum mechanics, and so on, but also in the ancient traditions, the Vedic lore, and the classical Sanskrit literature. So in this first book of 1995, he mentions a spund, which is the kind of vibration that has particularly attracted my attention, and the Akash, and then identifying the Akash as the quantum vacuum occurs toward the end of the book on page 342. The next step in my story is a paper by Rickwart and our Shishi Roy. It's called this Quantum Space-Time as a Statistical Geometry of Fuzzy Lumps and the Connection with Random Metric Spaces, published in 2001. So I would never have come across this paper except for the accident of my being invited to ISI Calcutta, where I was invited to give a talk. I forget about what. And after that, I met Professor Roy, and he told me about this work, and I immediately saw that it fit into my research program. So that began our collaboration on this idea. And it's a pretty difficult paper to read, I would say, but I'll just share with you the abstract. It's a little dim. Can you read that? Okay, so a kind of pre-geometry consisting of a web of overlapping fuzzy lumps which interact with each other. And graph theory is used to analyze this web of overlapping fuzzy lumps. Our work together finally resulted in this book, Demystifying the Akash, Consciousness and the Quantum Vacuum. Ambitious title and subtitle, and what's inside is extremely simple, I think, easy to read and understand, and whether you would agree with the title or not, I'm not so sure. The illustration on the cover comes from a research project I did many years earlier in the simulation of Rupert Sheldrake's idea of morphic resonance. So along the line of Punda, about the identification of the Akash and the quantum vacuum, there are a couple other authors, I'm not sure if they're earlier or later, who are relevant. One is Irvin Laszlo, who has a series of books on the Akash and the Akashic field, I think he calls it. And the other is Rupert Sheldrake, noted biologist of the United Kingdom, who had spent 7 years in South India in the ashram of Father Bede Griffith, the Christian ashram in Tamil Nadu. And during his time there, he wrote this book about morphic resonance, in which it seemed to me he had tried to re-express what he had learned of the Hindu tradition and sacred science in a language that scientists of the Western world could understand. So nothing unnatural is presented. It all looks like science, even though he became very controversial. So I met him in 1982, and I loved his ideas, and we had this Indian connection in common. So I tried to help him popularize his work by creating kind of a documentary film, including a computer graphic simulation of his morphic field. And this is just one of the images. At that time, in the mid-1980s, our computer graphic equipment was very primitive. We used a very expensive Silicon Graphics workstation and programmed these graphic images entirely in the C programming language and the OpenGL vocabulary of three-dimensional graphics. I'm not going to drag you through any part of the book, but here's what it says. I think this is on the back cover. this book sets out to prove, this is modest, to prove the compatibility of the scientific outlook and the spiritual non-duality of India. The mathematical model of Requart and Roy is atomistic. It's a discrete model. It consists of a finite number of points, some of which are connected by a directed link, and both the points, the nodes, and the links carry a certain weight and number, and these change as time advances in very tiny steps according to a rule, which is supposed to relate to the actual quantum physics of the quantum vacuum, I guess. But I just adopted it for the Akash, and taking over the same rule, but of course we would not really have a useful model unless we knew the rules. It'd be like approaching the theory of general relativity without having the Einstein equation. We just say, well, we know there could be some equation that if we plugged it in there, we'd get some interesting results. But it is computable. It's computable if you've got a fast enough computer or you're willing to wait a long time. So that's just background. I'm not trying to sell you the book, although there is a recent review of the book which I think is more informative than the book itself. So in a few pages you could get an idea about the subject better than mine. Now about math cognition, here of course is where I have my primary personal experience of mathematics, and in order to explain my understanding of my own personal process of mathematical discovery, I want to refer to some maps of consciousness. So here I've made a little chronology of the gradually increasing complexity. The shamanic religion, of course, the religion, the first one and only, evidenced in the painted caves in the south of France and so on. 3 levels, that's the ordinary reality, and a level downstairs, that's the basement, and then upstairs on the first floor. Then in the Sanskrit literature you have Panchakosh, and I think that this is probably the source of Plato's model with his 4 levels, which I of course became familiar with long before I learned of the others. For Plato, the top level, he called it the good. So he, like many of us, trying to avoid the word God, he called it the good. And then you have the intellectual sphere, and this is where all his Plato's famous ideas are stored in a gigantic closet full of blueprints for things that could perhaps be materialized in ordinary reality downstairs. And then in Kashmiri Shaivism, you've got probably the ultimate interpolation of additional levels, but I like it because it is very complete. It starts at the top with the good, basically, but it's called Shiva. There's Shiva and Shakti, and then as you go down, you get more and more levels of denser and denser, and the different levels are supposed to be coupled together by something like morphic resonance, which in the literature of Kashmiri Shaivism is called spund. And after you get down a ways, then you come to a group of levels that are called Maya, which are of course opaque to ordinary humans. So if you're downstairs, you can look up, you can't see the whole of the sky. There's this cloud layer called Maya. And then after some more levels, space and time are defined, and then you get the individual consciousness as a kind of a drops of rain in a huge cloud, which is cosmic consciousness, you see. So there's a transition to the individual level, and then finally down lower you have the levels of the 5 senses and so on. So I'd like to just specialize in one of these. I think this is the simplest one that helps me to talk about my process of mathematical cognition. So these are the 5 kosh, and at the top is the bliss level, and at the bottom the physical level. And then there's an energy level and a mind level and an intellect level, and these two particularly correspond, these four, leaving out this gray one here, the energy level, correspond to Plato's 5 levels. So as far as mathematical perception is concerned, what is a mathematical object or idea, or where is a mathematical object or idea? So following Plato and my own experience, I put a mathematical idea here on an intellectual level, and the mathematical object as perceived in mind here in the mind level. And that's all there is to it. In preparation for this meeting, this is one reason it's been so good for me to come here, is I had to promise a title in abstract far in advance. So I wrote a paper that I thought would be appropriate. It was called Math and Mysticism, and then as time went on, during the summer, I realized that it was totally inappropriate for this conference, although the ideas kind of fit theoretical way. It wasn't something that I could really present here. So I wrote another one in which I recast my personal experience spread it over the whole history of mathematics, and selecting from the whole history of mathematics certain very significant mathematicians like Kepler and Newton and so on, that I knew had mystical input to their creative work. And then I decided that one was too boring. So in the end I wrote 4 papers. They're all posted on my website, and what I'm presenting today is just skimming a couple of ideas from each one. So in case, in the unlikely case anybody was interested in like a reference or how to spell a word or a name or anything like that, the dates, all the details can be found in these articles that are posted on my personal website. So here's the first actual something here. I claim that we have a mathematical object and a mathematical idea, and then we have the perception of it, and that these two, the mathematical object in the intellectual sphere and its representation in mind, are connected by some kind of resonance process, like spund or morphic resonance. And I've made it bidirectional here, giving kind of a nod to the phenomenology of Francisco Varela and so on. So if we had, let us say a cube would be a typical mathematical idea, then there's the idea up here, and then there's my mental image I get of a cube. When you tell me cube, and then this image will pop up in my mind. And on the other hand, if I had a physical cube, an approximate cube made out of, carved out of wood, then that would be way down here. So the first thing, this is a little subtle, I'm suggesting that the mathematical cognition is in no way related to the ordinary visual process involving the retina, the optic nerve, and the visual cortex, etc. So here's the same picture with the perception of the block of wood, cubical block of wood put in. So we end up with the visual process is also a kind of a resonance, let us say, that could be described in the language of neurophysiology. And from the cube, the wooden cube, I also get a mental image of a cube. So what I'm suggesting here is that these two perceptual processes are totally or almost totally independent. And that's called the disjunctive theory, the disjunctive model in the theory of hallucinations, which began with Descartes. And for most of the history of this theory of hallucination, the two kinds of visions, hallucinatory and real visual perception, were identified. Nobody questioned that until relatively recently. And that recent questioning was very useful to me, because it gave a kind of a theoretical or pseudoscientific justification for the way that I had been understanding my own experience of mathematical vision or perception. So, summarizing the four papers, here's all really I have to say. I think that mathematical cognition is a form of meditation. So, as I started my mathematical career, I began meditating. I didn't know it as meditation, but now I could see, having learned several schools of meditation, that as a matter of fact, doing research on the mathematical frontier requires a kind of a meditation, either focused meditation or an insight meditation. Furthermore, the practice of ordinary meditation is very helpful for doing mathematical work. It increases the clarity of mathematical vision. I don't know why, although I've got quite a few ideas from the talks here today. Furthermore, on the basis of personal experience, and I think I'm not the only one to make this report, mathematical cognition is greatly furthered by psychedelics. That is to say, if you have a successful psychedelic experience once, then your mathematical perception will be improved forever. And finally, the point that I just made on the diagram, that mathematical cognition and ordinary vision are completely disjunct, if I may borrow that word from the disjunctive theory of hallucinations. So I suppose that these imaging processes are kind of similar or parallel processes and shouldn't be identified, but the study of one could help understand another. So regular vision, mathematical vision, I've talked about those. Psychedelic vision, well, you probably have heard that most psychedelics, not all, produce amazing visualizations. And the abstract animation that I was showed, as you may have seen on the screen while you were coming in, is an artwork by a computer graphic artist named Spot, S-P-O-T. It's called Electric Sheep, inspired by a book called Do Androids Dream of Electric Sheep? Is a question, is the title of one of the most famous books by our greatest American author, Philip K. Dick. And so Spot was inspired by chaos theory and by Philip K. Dick to produce an artwork. Now there are thousands of these abstract animations. They last about 4 minutes, and they are extremely reminiscent of psychedelic visions, and that is why I start all of my lectures, each and every one, by showing one of these artworks of Spot. In meditation, you have visions, and of course there are many artistic representations of these visions in the literature of all traditions. The dream images also have been drawn, and of course hallucinations, a word that covers a host of different phenomena. I think they're similar processes, but they shouldn't be identified, in my experience. So here's the earliest example I've been able to find of the disjunctive theory of hallucination. It's due to Baudelaire in 1857. Baudelaire was one of these writers, wrote kind of prose poetry, so a very artistic fellow whose work was inspired by a very serious addiction to hashish, that's charas, and opium. So besides all his artistic works, he wrote something like I'm trying to do now, to give a first-person account of my artistic process. He said, when I speak of hallucinations, the word must not be taken in its strictest sense. A very important shade of difference distinguishes pure hallucination, such as doctors have often have occasion to study, distinguish from the hallucination, or rather of the misinterpretation of the senses which arises in the mental state caused by the hashish. So in the theory of hallucination, I've included him in the usual list as a little-known stranger among the milestones of the theory of hallucination, with Plato, of course, with his dream in the cave in the Republic, and Descartes' famous dream, which was caused a sensation in philosophy that still hasn't subsided, and then Baudelaire, which I've interpolated into this list, and of course Poincaré in 1904. Now, Poincaré, how many people have heard of Poincaré? Yeah, well, quite a lot. So Poincaré was arguably the greatest mathematician of all time so far, and I think the second contender is Euler. So in terms of the rate of production, Poincaré is about equal to 2 Eulers, and I'm equivalent to 0.001 Euler. But different from every other prolific mathematician, Poincaré, because I'm in his line, so my estimate of his importance in the history of mathematics might be slightly tainted. But uniquely among them all, he wrote down, as I'm trying to say now something but not much better, he wrote down an account of his process of mathematical discovery, excepting he called it mathematical creation. So there's a kind of difference of opinion there between me and Poincaré, because I agree with Plato that mathematical objects are discovered, but Poincaré thought that he was actually inventing all these things, which he might be right. I can't prove which idea is correct. Maybe this attains to the word reality in the description of this session. Reality, physics, and mathematics. So this is what he said. He described a process. I'd go on in detail about it, except we've seen it this morning in the talk of Rajan on the creative process, and then it was attributed to somebody else, I think a later writer, but this is exactly what Poincaré said. You do a whole lot of work struggling with concepts, and you have an idea what you want to do, and you just can't do it. You get all frustrated, and then you set it aside. Then you go on a picnic with the children, have lunch, and then later on you come back and maybe go to sleep, and in the middle of the night you wake up and you have an idea. So he identified the unconscious. He had another name for it. But the unconscious was doing the work with a manipulation of the mathematical ideas that had been ingested, as it were, before the picnic. And the unconscious reassembles these blocks in different constructions and trying to make something, and figures out something, and then there's a illumination, it's called, as into the conscious mind, the product of the unconscious work pops out, all done. He tells a story when he was going on the bus. When he put his foot on the bus, the whole thing came to him. The theorem, the proof, the way of presenting it. He was so sure it was right, he just stepped right onto the bus and went on to a picnic. And later on, he wrote it all down. So he had so many creative experiences of this sort, and he analyzed them so well, and he came up with this theory, which is more or less the theory of creativity that we have today. So that's the story I wanted to tell you. Here are some references that I've mentioned. More details can be found in my literature, and here's my website. If you go to this website, and there's a long menu, and if you click on articles, then you will find these numbered articles, manuscript number 144 and so on, in chronological order. So there you have it. Thank you very much.
Thank you very much, Ralph.